Hello, this is a learning video in which we are going to learn how to draw and how to name functional organic molecules that have functional groups, and the specific functional groups will be carboxylic acids, ketones, and aldehydes. So looking at the functional group of a carboxylic acid. A carboxylic acid is one in which there is a double bond oxygen and a OH at the end carbon. So when you look at what we have here with the general structural formula, and you take a look at what would be, the look for you to classify that as a carboxylic acid, it would be that double bond oxygen and the OH that happens on an end carbon. You're going to know that it is a carboxylic acid because it ends in the word oic acid. So here is the first example. You could have methanoic acid, and with methanoic acid you would have one carbon because meth stands for one carbon. That carbon would have that double bond oxygen and an OH. That is the molecular formula for the molecular structure for methanoic acid, and it has a molecular formula here of CH2O2. Okay, so that is the molecular formula for methanoic acid. You could have a structure like ethanoic acid, F standing for 2. You know that it is an acid, so 2 carbons, double bond oxygen, OH. That is ethanoic acid. This has a common name. Ethanoic acid is also known as acetic acid, or it is commonly known as vinegar. Sometimes how we would show the molecular structure for ethanoic acid, you could use the same system that I was using before, which would be C2H4O2. However, commonly you'll see ethanoic acid show its structure as CH3COOH. So that is a common molecular formula showing the structure of ethanoic acid. Propanoic acid, as you take a look at that one, propanoic acid, prop meaning that you have 3 carbons. So with propanoic acid, you would have 3 carbons, double bond oxygen, and an OH. Its molecular formula is C3H6O2. Butanoic acid, you would have 4 carbons. So you can see the pattern here. The prefix tells you how many carbons. The functional group is a double bond oxygen and an OH on the end carbon. So this would be C4H8O2. That is how you draw carboxylic acids if you were given a name. If you were given a structure, again, you're going to look for that functional group, the double bond oxygen OH, and you should be able to classify that as a carboxylic acid. Ketones are similar to carboxylic acids in that the double bond oxygen, though, is on a middle carbon. And we pronounce ketones that they end in the word "one." Okay, so here is the functional group. So it's kind of a look for is just that double bond oxygen on a carbon. So the simplest ketone you can have is propanone. So that would be 3 carbons with a double bond oxygen. That is the molecular structure for propanone. Its molecular formula would be C3H6O. That is propanone. Butanone would have 4 carbons. And with those 4 carbons, you could have that double bond oxygen on that first or that second carbon. Again, remember it has to be a middle carbon. and that would have a molecular formula of C4H8O. That is its molecular formula. If we take a look at this molecular formula, and we take a look at, let's just move this around, and let's flip that. So we're going to flip it from left to right, and we have that double bond oxygen on that carbon now, which is still the second carbon. You'll notice that that is still butanone. So you do not have to put a number of where that functional group is until you get to pentanone. So we're going to look here. I'm sorry, we're going to do flip. We're going to go back to where we were for that. And now when we get to pentanone, you'll notice when we get to pentanone that there are 5 carbons because pent is the prefix, and that 2 now tells us where that double bond oxygen is. Its molecular formula for pentanone would be C5H10O. If we take a look at 3-pentanone, the difference is that that double bond oxygen is on the 3rd carbon instead of the 2nd carbon. 1, 2, 3, 4, 5. Here's the double bond oxygen. It has the same molecular formula, but different structures. These are called isomers. They have different physical properties. They will have different melting points and boiling points. Albeit close, but they will be slightly different. So that is how you name ketones. The last group we're going to talk about today are aldehydes. And aldehydes are similar to ketones in which the one double bond oxygen is on the end carbon. And so here is the functional group. You'll notice that that double bond oxygen's on the end carbon, and we called aldehydes end in Al, so they're al. They end in the letters Al. So you have methanal. Methanal would have 1 carbon, and that 1 carbon would have a double bond oxygen. So its molecular formula would be C2H2O. If you'd recall, there has to be a hydrogen. Every carbon needs to have 4 bonds, so there'd be 2 hydrogens on that. Ethanal would have 2 carbons with that double bond oxygen being on the end. This would be C2H4O. Propanal would have 3 carbons with that double bond oxygen on the end carbon. This would be C3H6O. So again, these functional groups, they get the priority of the lowest number possible, just like a multiple bond would. So we're going to do one you try. What if you had an aldehyde that looked like this? And you had a methyl group coming off that. How would you name that? What is the first carbon? Well, in this instance, this would be the first carbon because that functional group, which is right here, gets the priority of having the lowest number possible. So that's first carbon, second carbon, third carbon, fourth carbon, fifth carbon. So this molecule, and you've got a methyl group branching off, would be called 4-methyl pent, because there's 5 carbon, N-al. So something to think about with those functional groups, they get the priority of the lowest number in the longest chain. All right, again, this is just a chart that is summarizing the 6 functional groups that we're studying, and you can see that the red circle's kind of the look for so that you could classify the functional group. You can see the general structure. Remember, R can stand for any number of carbons, and you have the IUPAC names, which tell you how that classification will end. That's the learning video on functional groups. I hope this helps, and thanks for listening.